encapsulation of fields such as nanotechnology, quantum computing, 3D printing, mobile networks, artificial intelligence, and neuromorphic technologies create realities that were unknown and unthinkable, transforming every industry for the better. All of these new paradigms will affect the very essence of the human experience and the human condition, referred to as cyber-physical systems. Deep learning in artificial intelligence. Each level learns to transform its input data into a more abstract representation. For instance, in an image recognition application, the raw input may be a matrix of pixels. Artificial neural networks. Neural networks feed forward back propagation network for supervised or unsupervised learning. Neural networks learn by example. They have been used in applications ranging from autonomous vehicle control to facial recognition. Artificial neural network is a computing model inspired by nature. It is a methodology mimic at a certain level the way the brain reacts to various inputs. When a neuron is excited by a stimulus and becomes active, it sends a small charge along this network, which in turn causes other networks to become active. Deep learning in applied neuroscience, artificial intelligence, neural network, algorithms. The basic strategy in implementing a neural network as a high-level program is to establish a framework of data arrays to hold the weights and to track accumulating totals as signals are fed forward and errors are fed backwards through the network. A sequence of nested for loops iterates through these arrays, making the various calculations required as the backpropagation algorithm is executed. Software algorithm and process initialize the arrays. The weights are set to random numbers. Begin a large loop that runs the system through a complete set of training data. Artificial intelligence, reconfigurable robotic systems are autonomous kinematic machines with variable morphology. Beyond conventional actuation, sensing and control typically found in fixed morphology robotic systems. These robots are also able to change their own shape by rearranging the connectivity of their parts in order to adapt to new circumstances and to perform new tasks. For an artificial intelligence autonomous stochastic robotic system to accomplish tasks when the outcome of actions is non-deterministic, it is necessary to apply error correction and error detection. In this segment, I will introduce a general framework that illustrates the implementation of inertial measurement system for artificial intelligence robotics applications. Here is a demonstration of an efficient orientation filter able to provide an estimate of the inertial measurement unit orientation relative to the Earth through the fusion of tri-axis gyroscopes and tri-axis accelerometer. Kalman filter allow the use of mathematical models to gain an estimate of a system state. By using Kalman algorithms, noisy accelerometers, gyros, and magnetometer data can be combined to obtain an accurate representation of orientation and position. This is an excellent use for robotic systems applications. The algorithm is computationally driven based on Kalman solutions used in this current application. The objective is to illustrate a demo in this video using machine vision technology in combination with a camera and artificial intelligence software algorithms to achieve image recognition. Image recognition, as it relates to machine vision, is the ability of software algorithms to identify objects, places, people, writing, and actions in images. Convolutional neural network takes advantage of the fact that in any given image, proximity is strongly correlated with similarity. That is, two pixels that are near one another in a given image are more likely to be related than two pixels that are further apart. In a typical neural network, every pixel gets connected to every single neuron. In this case, the added computational load actually makes the network less rather than more accurate. Image recognition convolutional neural network algorithms can function by use of comparative 3D models, appearances from different angles, using edge detection. Image recognition algorithms are often trained on millions of pre-labeled pictures with guided system learning. Pooling layer, which takes several dimensional arrays and applies a downsampling function alongside the special dimensions. The result is a pooling array containing only those parts of the image that are more important while discarding the rest, which both minimizes the computations that are needed to do while also avoiding the problem of overfitting. The neuron transfer. Once a neuron is activated, the need to transfer the activation to see what the neuron output actually is. Different transfer functions can be used. It is traditionally to use the sigmoid activation function, but you can also use hyperbolic tangent function to transfer outputs. The sigmoid activation function looks like an S shape. It's also called the logistic function. It can take any input value and produce a number between 0 and 1 on the S curve. It is also a function in which you can easily calculate the derivative. Artificial intelligence, quaternion, Kalman mathematical models are used in this illustration of industrial robotic system applications. Quaternion and Kalman filter algorithms. This framework illustrates a quaternion-based Kalman filter algorithm for real-time estimation of the orientation of robotics application systems. Quaternions are used to represent rotation, relationship between navigation framework and body frame. Processing a 3-axis accelerometer using adaptive step gradient descent software produces a quaternion input to the Kalman filter. The Kalman filter algorithm combines 3-axis gyroscopes with 3-axis accelerometer with computed quaternion to determine pitch and roll angles. A quaternion-based Kalman filter fusing measurements gathered from robotic, kinematics, and inertial centers at different sample frequencies in order to estimate linear accelerations and angular velocities, accelerations of load. The recursive total process is executed to identify the load parameters. This frame of work presents the basic fundamentals from a system architecture. Some of the important technologies required to build a cognitive, thinking, artificial intelligence robotic system. In previous videos, I have illustrated several engineering prototypes representing actual architectural models, including telemetry system, inertial measurement system with integrated gyroscope, accelerometer, and magnetometer. These technologies are used by industrial robotics for equilibrium, balancing, as well as orientation purposes. The core of the robotic system includes the neuromorphic CPU in conjunction with the support of complex mathematical algorithms, software Kalman quaternion filters, servo motor control algorithms. There are other programs embedded in this robotic application within the realm of artificial intelligence paradigm, that is machine learning, cognitive mathematical representations, and convolutional neural network software models. In this application, I have exposed all the software intellectual property integrated at a system architecture in firmware, mathematical algorithms, machine learning, cognitive software models, and neural network artificial intelligence programs. The quaternion Kalman mathematical models are used in the engineering prototype, as I have shown in this video, in order to filter out different types of environmental noise conditions introduced by the magnetometers, the gyroscopes, and the accelerometers. Error correction and error detection, mathematical models and algorithms and filters solve all of these issues at the system level. Data fusion based on Kalman filter. A data fusion method based on the Kalman filter is described in this application. So you could see that the measurements of the accelerometer and magnetometer are used as the input of the two-step geometrically intuitive correction to produce the computed quaternion. And the computed quaternion is used as the measurement of the line Kalman filter in order to correct the predicted state obtained by using the output of the gyroscope. Quaternion Kalman filter for real-time estimation using geometrically intuitive correction algorithm. In this algorithm, the sequential geometrically intuitive correction is used to make the estimation of pitch, roll, immune to magnetic distortion. Meanwhile, the software algorithm produces a quaternion input for the Kalman filter to reduce linearization, error of measurement equations. The artificial intelligence multi-layer is composed of input node layers, hidden node layers, and output node layers. They specifically integrate the inputs and feeds the information to the outputs. Computational neuroscience is a branch of neuroscience which employs mathematical models, theoretical analysis, and abstractions of the brain to understand the principles that govern the development, structure, and cognitive abilities of the nervous system. Feed-forward neural network. As a neuron model, each neuron calculates the weighted sum of its inputs plus a bias, then computes an activation value and sends this value to the next layer of neurons. Each neuron of the previous layer is connected with a certain weight, and these weights start random and are learned during training. A trained neural net is equal to the structure plus learned weights. Also, artificial intelligence forms part of the cognitive engineering science, which is the scientific study of the mind and its processes. It examines the nature, tasks, and function of cognition. These neuromorphic architectures model in silicon the massive parallel way the brain processes information, as billions of neurons and trillions of synapses respond to sensory inputs such as visual and auditory stimuli. Those neurons also change how they connect with each other in response to changing images, sounds, and the like. That is the process we call learning. These architectures, which incorporate brain-inspired models called neural networks, do the same. That is why I have created this neuromorphic architecture / platform. It is physically building the circuitry, that is the neuron structure of artificial neural networks, directly onto the platform. Since the neurons are physically transistors, they are electrical components. They use less power than software networks, which have to simulate the entire neural network. Neuromorphic engineering science is based on two principles, that is neuromorphic modeling and neuromorphic computation. The neuromorphic modeling, reproducing neurophysiological phenomena to increase our understanding of the nervous system, and neuromorphic computation, using a subset of neuronal properties to build neuron-like computing hardware. That is the platform that I am presenting in this video. Deep learning in artificial intelligence. Each level learns to transform its input data into a more abstract representation. The objective is to illustrate a conceptual design and to model a convolutional cognitive neural network artificial intelligence algorithm. Backpropagation used in artificial neural networks to calculate a gradient that is needed in the calculation of weights to be used in the network. It is commonly used to train deep neural networks with more than one hidden layer. It requires the derivative of the loss function with respect to network output to be known, which typically means that the desired target value is known. The learning algorithm can be divided into two phases: propagation and weight update. Phase 1 is propagation. Each propagation involves the following steps. 1. Propagation forward through the network to generate the output values. 2. Calculation of the cost. 3. Propagation of the output activations back through the network using the training pattern. Target to generate the deltas, which is the difference between the targeted and actual output values of all output and hidden neurons. The neural network algorithm corresponds to a function which, given a weight, maps an input to an output. The optimization takes as an input a sequence of training examples and produces a sequence of weights, starting from some initial weight, usually chosen at random. These weights are computed in turn. First, compute using only 4. The output of the algorithm is then given a new function. The computation is the same in each step. Calculating from is done by considering a variable weight. Convolutional neural networks are networks that use many identical copies of the same neuron. This allows the network to have lots of neurons and express computationally large models while keeping the number of actual parameters. Convolutional layers work on higher dimensional data also. In fact, the most famous success of convolutional neural networks are in applying 2D convolutional neural networks in order to recognize images. In this code, the list sizes contains the number of neurons in the respective layers. To create a network object with using the NUMPY NP random rand_n function to generate the Gaussian distributions with mean 0 and standard deviation 1. This random initialization gives our stochastic gradient descent algorithm a place to start.